Alright, what I want to look at first is multiplying two different problems. The first one, x plus 4 times x minus 4. X times x is x squared. X times negative 4 is negative 4x. We have our inside, 4 times x, plus 4x, and then 4 times negative 4 is negative 16. Negative 4x plus 4x, those cancel. And that just gives us x squared minus 16 when we multiply. Okay, now let's look at the second one. 2x times 2x, that is 4x squared. 2x times negative y is negative 2xy. And then y times 2x is plus 2xy. Y times negative y is negative y squared. Negative 2xy plus 2xy, they cancel. You're left with 4x squared minus y squared. Now, what happened to the middle terms on both? They both ended up canceling. Okay, so if you look at this, these were both x, and that was a positive 4 and a negative 4. On the second one, 2x and 2x, and then y and negative y. One's positive, one's negative. So this is what's called the factoring of the difference of two squares. Okay, difference of two squares. If, and it's called a squared minus b squared, if you have a squared minus b squared and they are both perfect squares, you can factor that a minus b times a plus b, or a plus b times a minus b. That's commutative property. It doesn't matter which order you do it. Okay, but basically you look for, if you look back, let me do this in red so you can see, to this one up here, x squared. What's the square root of x squared? That was x. 16. What's the square root of 16? That's 4. One's plus, one's minus. Okay, if you look at 4x squared, what is the square root of 4x squared? Well, square root of 4 is 2, and square root of x squared is x, so that's 2x. And 2x. And then y squared, the square root of y squared is y. One is plus, one is minus. Okay? So, when we are factoring n squared minus 64, this first example down here, well, what can we multiply to get n squared? That would be n times n. And then, what's the square root of 64? Or what can you multiply by itself to get 64? That's 8 times 8. And difference means we subtracted, okay, so just make sure that's a minus. But when you have the square root of each one is plus, one is minus, and that is it. That is your answer. Okay, the second one, 4m squared minus 81n squared. Well, are they both perfect squares? Yeah, 4m squared is 2m times 2m. 81 is 9n times 9n, right? 81n squared, so 9n times 9n, 81n squared. Alright, so here the square root of 4m squared is 2m. The square root of 81n squared is 9n. One's plus, one's minus. And that's all there is to it. Okay, really, when it is what is called the difference. Now remember, difference means to subtract. So when you have the difference of two perfect squares, if you can multiply something by itself to get each part of this, that's when you just factor n plus 8, n minus 8. Or 2m minus 9n, 2m plus 9n. Okay, let's look at one more example. Now, a note here is you may need to take out the greatest common factor before you can see the difference of two squares. Alright, so let's look at this one. Do we have a greatest common factor? Yeah, 2 goes into both of them, and you can take an a out of each. You can take a 2a out. We're left with, we took a 2, so divide by 2a, we're left with a squared, minus 98 divided by 2 is 49. A cancels, so you'd have 49b squared. What can we multiply by itself to get, so we have this 2a out there, and then what can we multiply by itself to get a squared? That's a. What can we multiply by itself to get 49b squared? That is 7b. One's plus, one's minus. And that is all there is to factoring the difference of two squares. Okay, you just look for the square root of each. You also look, you may need to take out the greatest common factor before. Okay, but that's it. Do the you try problems, and we'll go over them in class tomorrow.